Hey, welcome. So think about this for a second. Every single day, your personal info, your passwords, what you buy, your private DMs, it all goes on this wild journey across the internet. Today, we're going to follow that journey and pull back the curtain on this incredible, invisible shield of tech that works around the clock to keep it safe. Let's dive in.
It's such a simple action, right? Something we do all the time without even thinking. You find that thing you want, you type in your credit card numbers, and you hit buy. But boom, in that split second, you've just sent your most sensitive financial data on a really risky trip across a massive global network. So what on earth is actually happening behind the scenes to protect it?
All right, so before we can even talk about the solutions, we first have to really get our heads around the problem. And the problem is that our data's journey starts at a place that is, by its very design, wide open, kind of chaotic, and totally exposed. In that place, that world our data travels through, we call it cyberspace. But it's not just, a bunch of cables and servers. It's this super dynamic environment of people, software, and services, all bumping into each other. You can almost think of it like a giant digital city that never, ever sleeps, and it's filled with good guys and, well, a lot of bad guys. And here's the core truth about the internet, the thing you really have to understand. It was built for openness, for connection. Security was kind of an afterthought. Think of it like a public square. If you just shout a message across it, anyone can hear it, anyone can intercept it, and anyone could even change what you said. That is, unless you protect it first.
So who really needs to worry about all this stuff? Well, obviously you've got your security engineers, your IT specialists. Of course, you've got banks trying to protect our money and governments trying to protect state secrets. But in the world we live in now, where everything is always connected, the real answer is everyone. Every single one of us. We're all potential targets.
So how do we even begin to protect ourselves in this exposed world? Well, the journey for our data always starts by passing through the very first line of defense, the main gates of our own digital fortress. And that gatekeeper? That's the firewall. Picture a bouncer at a nightclub or a guard at a castle gate. It has one job and one job only: to check everything and everyone trying to get in or out, and to enforce a super strict set of rules about who gets to pass. It's the absolute essential perimeter for our private network. Now, for a firewall to actually be effective, it has to live by three core rules. First, it's got to be the one and only way in or out. No secret backdoors allowed. Second, it has a strict guest list, a security policy that decides what gets in and what gets blocked. And third, and this is crucial, the gatekeeper itself has to be tough as nails, totally immune to attack. Okay, so our data made it past the firewall. That's great, but now it has to travel across that wide open, totally unsafe internet. And just sending it out there is way too risky. What it needs is its own personal armored convoy. To build that convoy, we need to create what's called a secure channel. And a secure channel does two absolutely critical things. First, confidentiality, which is just a fancy way of saying nobody can eavesdrop on your data while it's moving. And second, integrity, which means nobody can mess with it or change it without you knowing. Your data gets there exactly the way you sent it. And two of the most common ways we do this are with TLS, that's the thing that gives you HTTPS and the little lock icon in your browser, and VPNs. The big difference here is scope. TLS is kind of like hiring a single armored car to take your money to one specific bank. It protects that one trip, and that's it. A VPN, on the other hand, is like building your own private underground tunnel system that protects all of your journeys, no matter where you go online. So building a secure tunnel is great, but what if an attacker somehow managed to break in? For our next layer of defense, we have to make sure that even if our data gets stolen, it's completely unreadable, just total gibberish to the thief. We need it to speak in a secret code. And that process is called encryption. It takes your normal, readable information, we call that plain text, and it uses a secret key to mash it all up through an algorithm. What comes out the other side is a scrambled, unintelligible mess called ciphertext. And without the right key, it's literally just random noise. Okay, so there are two main flavors of encryption. You've got symmetric, which is super fast and simple. It uses one single shared key to both lock and unlock the data. The tricky part, though, is how do you get that secret key to the other person securely in the first place? Then you have asymmetric. It's way more clever, but it's also slower. It uses a pair of keys, a public one to lock the data and a private one to unlock it. So here's how that magic works. Think of the public key like an open padlock that a website just hands out to everybody. You can take that padlock, put it on your message, and snap it shut. But here's the cool part. Once it's locked, the only thing in the entire world that can open it is the website's unique private key. It's a genius way to send a secure message without having to share a secret password first. So, which one do we actually use? Symmetric or asymmetric? Well, the really clever answer is both. Modern security, like the stuff that powers TLS, uses the best of both worlds. It starts with that slow but super secure asymmetric method for just long enough to safely agree on a temporary secret key. Then, for the rest of the chat, it switches over to the fast and efficient symmetric method using that new key. It's a hybrid approach that gives us rock-solid security without slowing everything down.
Okay, so check this out. Our data is now inside an armored convoy and it's speaking a secret language. But there is one more huge problem. How do we know the convoy actually arrived at the real bank and not some fake lookalike set up by a clever scammer? How do we prove identity online?
The answer is a digital passport. You'll also hear it called a digital certificate. This is basically a standardized file that acts like a recognized ID for the internet. And it's issued by a trusted third party, called a certification authority, or CA. The CA verifies that a website is who they say they are, and then they issue a certificate that officially links their name to their public key. And this whole system creates something called a chain of trust. See, your web browser comes with built-in trust for a handful of major root CAs. Think of them as the world's most trusted passport offices. So when you go to a website, it shows you its certificate. Your browser looks at the digital signature on that certificate, and if it was signed by one of the CAs it already trusts, it goes, yep, looks good, and you know the website is legit. So let's take a step back. We followed our data through the gates, across the big bad internet in a secure tunnel, speaking a secret code, and all the way to a verified destination. Now let's put it all together and see this amazing invisible shield in action. These are the guardians of your data's journey. You've got the firewall acting as the tough gatekeeper. You have TLS or VPN providing that armored transport. You have encryption, the secret code that makes the data totally useless if it's intercepted. And you have certificates, the digital passports that make sure you're talking to who you think you're talking to. Each layer provides a different, absolutely essential piece of the puzzle. And this quote right here just nails the most important principle of modern cybersecurity. It's called defense in depth. Look, a firewall is critical, but it's only the beginning. You have to have multiple, overlapping layers of security because you have to assume that one layer might fail and you need another one right behind it to stop an attack.
And why does this matter so much more today than ever before? Because we are rapidly moving into a world that is always connected. It's not just our computers and phones anymore. It's our watches, our cars, our fridges, a massive explosion of so-called Internet of Things, or IoT devices, and they are all sending data on that exact same perilous journey.
And that brings us to our final question, the big one to think about. These fundamental ideas, the firewall, the secure tunnel, encryption, authentication, they've served us incredibly well. But as billions and billions more devices come online, as the very fabric of our daily lives gets woven into cyberspace, how is this invisible shield going to have to change, to adapt, and to evolve to keep us all safe in the future? Thanks for watching.